Bismillahirrahmanirrahim. Welcome back, dear students and friends. In our previous demonstration, we had seen how we can use an array to organize our GPIO pin references and access the GPIO pins through their index number. So whenever IO lines, they are not in order of GPIO pins on the microcontroller. They are haphazardly distributed. Some is distributed to PA15, some to PA3, some to PA17, and not PA17, PA15 and 13, etc., etc., or even to another port for that matter. It becomes really sometimes odd to remember their position and access them in a sequential or regular order. So this technique is good enough to make the pins an order so that you can access them through their uh, index number in the array. And then you access those pins through using your uh, Hall function, but instead of giving the pin number, you give the reference to the um, array, and that will access the required pin. Now, in order to make your code more organized and more structured, it is a good idea to make the code uh, abstracted from the main usage by putting them into the functions. Just like here, you can see here is a function which has been made by the cubemx itself, which is the system clock configuration function. And here all the code to set up the configuration of the clock is written. Then is there GPIO initialization function, etc., etc. So these functions, they actually uh, hide all these functionalities which are to be written to access the functionality of this code. Uh, and when you write them into a function, you just call that function. So although we have a very simple command, yet only one line of command, which may not need to be put in a function, but just for the sake of simplicity and for the sake of demonstration, I would show you how to organize this code into a function and its requirements, how to call the function, how to make your function, and then later on we will move this function to a separate file altogether and make your own library which is reusable. The idea behind the functions is to make your code reusable so that once you have made an effort to write a function or a procedure which consists of many lines of code, then why not to use the same code in another project? Why to write the same code again and again? Excuse me. So this is the basic idea behind writing the organizing the code into the functions and then the functions into a library. So we will be building our library step by step. So for the just for demonstration, I will first make this code as a function. So when you make it a function, you just let's say uh, copy it and we just comment it out so that it is no longer used. So in your uh, area where they have defined a user code area, here you can make a function. So to make a function, you have to give it a name, right? Like I want to give it a name just like the Arduino function, digital write, digital write. And then you provide it that what parameters it will accept. So one parameter it will accept will be the pin number on which will be the index number of the array and also the state whether you want to turn it on or off. So and GPIO-A will be our standard port, so that need not to be passed. So let's say we write uint 8 underscore t pin comma boolean uh, state. It can be a number, it is just 0 and 1, but a data type of bool is boolean, which can be only true or false or 0 or 1. So this is a good idea to use the boolean function, but the boolean data type. I will show you that boolean data type is not the standard data type, so we have to add a reference library for that. And then you start the function, and in this function you paste the code which was copied from our main function. So here GPIO A will remain the same, and here you will use the reference to the array pins of 7. Instead of that, we will use pins of pin, this one. And instead of GPIO set, we will use the data passed as state. Now, since this function is not going to return any value, so we will label this as void return type. Void means nothing. So this function is going to accept these two parameters, pin number and the state, and it is not going to perform this function, and it will not return any sort of data back to the calling program. Now, in order to use this function, we have to define this data type or this function type, uh, which is called its prototype, before the before using it, because we will use it here, like in this place, anywhere there. Because here we will call digital write, and we will say pin number 7 comma true. This is what I want to say. But when this program will be compiled, it does not know what is this function, because this function is defined lower down. So in order to define it, you have to define the prototype of this function uh, anywhere outside the main program. Let's say we define it, we can define it here. So this defines that we are going to use a function named digital write, and it expects an unsigned integer number of pin and a boolean variable of state. Now, if we compile this program, we will end up with an error, like if you compile it. So there are 4 errors. So the main error is this, that it does not know what is this bool type. So bool type or boolean type is not defined. So in order to get that, we include another file, hash include std bool.h. Remember, when you include a header file with these less than and greater than signs, this is a system defined include file which is part of the compiler. And when you include a file within the inverted commas, that means this file is part of your application or your part of your project. Now let's compile it and build the project. Now there are no errors. Now this program can be seen working in the this is right, GPIO hex, and pin number 7 should 0 1 2 3 4 5 6 7, which is this PA15. This should turn on, and as you can see, it turns on. Now in your program, you don't need to write this code again and again, and all we need is to call this function anytime we want. Now let's say if we want to access this in a loop, like I make a loop for int I is equal to 0, semicolon, semicolon, I is less than 10, semicolon, I plus plus, and then I write this function inside it, control V, and instead of this, I write I and hall underscore delay of, let's say, 500 milliseconds. Right, now let's build this program and see its results. It is sequentially turning the LEDs on from 0 to 9, and it is doing it again and again, but since these are already on, we can't see those overwriting these. So this is how you write a function, and now you have to call this function. You don't have to remember the hall code, you don't have to remember the port, you don't have to remember the anything else, and you just pass it on the value of the variable, which is 0 to 9, and that there you are. If the pin connections change, you can just change them in this array, and these will redefine your uh, array connections. So this was good for organizing the code and making the function in your same file, which is the main.c. Though you can make the functions in your main C file just like this, but it is always a good practice to write your custom code into separate files so that you can organize them in a more orderly way. You can debug them properly and easily, and also you can share those code in other projects or with other friends or other team members as well. So we will now convert the same code into a uh, more organized way. That is, we are going to make our own library. So see how we do it. So normally we have this structure of uh, our program, our project, which has a binaries folder and includes folder, which contains all the include files which have been generated by the our uh, CubeMX, and there is the core where you have this source files, and here you place a source file. You can place a source file here as well, which will be part of this SRC folder, and that file will automatically be included in your uh, compilation. However, I personally prefer another or more organized way, and that is just by clicking the right button on the project, add the new, and add a new source folder. So this will be a folder which will be actually a source files. So it is being included in the one.gpio, and I name it, let's say, micro by the name of our organization. So this folder is empty as such. Now in this folder, I include a new source file, which is C file. So it can be any name, but I just want to name it as micro.c. But it can be any name. It can be GPIO, it can be LEDs, it can be LCD, or it can be anything. Micro.c. Remember to add the C at the end of the file name. So here is a bare necessary file which has nothing else, only a comments. You can write the here comments about who has written it, what is the purpose of this file, etc., etc. And now we paste the code here, our digital write function. This was our digital write function. So we just copy it, we cut it from here, and we paste it here. So this is the function uh, which is being called here. Since it is also using the bool uh, uh, data type, so we have to hash include std bool dot h. Now the prototype for this function, which is this, and which we defined it here in the early part of our program, should also be defined somewhere. Also, this constants which are part of the our function, so we cut it from here and we also paste it here. Remember, these are not part of the function, so these are global uh, attributes which can be called from a number of other functions as well. Now we have to cut this definition, and this definition must be placed in a header file, new header file. The header file name should be the same as the same C file like micro.h, although it's not necessary, but it's a good idea to have the same name. So when you place it, it has defined that if this file has not already been included, it should be defined and should not be re-included. So you will place the code inside this if definition. And we place this here. And again, it will need this definition for this bool. So we also include hash include std bool.h. Right. Now, in this micro C program, we also include the definition of that uh, program, that header file, hash include. Now, this will be in inverted commas, and if you press M and just control space, it will give you this micro.h file. Just save it. Now, our library is complete. And in our main program, we just include that file hash include micro. So see, if I'm pressing the control and space, it is not detecting that micro.h. And even if I include it, when I will compile this program, this will give us an error. See, there are 15 errors. And the error is it does not know what is this GPIO pin for and etc. etc. So first thing is that in our this micro C program, we have included these definitions of GPIO pin 0, GPIO pin 1. These definitions are defined in your microcontrollers include file. If you go to this main.c and if you go to this main.h file, so here you will see it has included a microcontroller definition file, this file. Hash include STM32 f1xxx.all.h. So we copy this definition and we place this definition in the micro C file. Control V. Now let's save it and now try to compile it. Project, build project. So now there are less errors and it does not know where is this micro.h file located because we are compiling the program in this folder core source while the micro.c file is located in this folder micro folder which it does not know. So we have to define the path to this folder. So for that you just click on the project name and go to its properties and open the C, C++ general and open the paths symbol. So these are the various folders in which the paths have been mentioned. So you just add a new path, add, and browse either from the workspace or from the file system. Just go to from the workspace and from GPIO, and this is the folder. Okay, and okay. So here that has been included in the path. Now if you compile the project, now there are three errors. What are these? Unknown type u int 8 underscore t micro dot h. So now we have fixed the error. This is the main h file, the std bool h and micro.h file. These have been included in the main program, and in micro C program we have included this whole microcontroller include file and this micro.h file. And again, this is the outside int 8 pin number, and the state is the boolean number. So let's build it. So now there are no errors, and you can see we have included this one line, digital write pin number 7 comma true. And now if we execute it, only pin number 7 will be turned on like this. Now if we write the same program in which we want to access the lines one by one, for int I is equal to 0 semicolon I is less than 10 semicolon I plus plus. Remember, when you give this int I, the I is declared as a private variable only for this function. This I will disappear when the function exits. If you want this I to be available all the time during this program, this function, this I should be declared as part of the function in top of the function. So digital write I comma true. This will turn the ith LED on. Let's say we delay it by 500 milliseconds, and then we turn it off. Digital, even if you press the control and space now, it will give you the IntelliSense which will automatically turn it on. And it is also suggesting that instead of pin, you might use this variable I. So we use this I, and state we use this word false. That will turn the LED off, and then it will increment it. So let's say if we build the project and see, so these LEDs are turning on and then turning it off one by one. So similarly, if you want to make a bar graph, we can make a function that should repeat this number of lines for I time, and that will display the bar. We will make that function in our next demonstration. So I hope you have enjoyed how to make this library. So in our library, this name micro C, we have included these pin definitions as global variables, and just one function which is digital write, and this is going to write this GPIO pins on the according to this uh, definitions. And now from the main program, then you have defined the path to this folder so that it can be accessed. And then in the source program, you have included uh, the micro.h definition file, and then you can call the functions. It is always better to include these functions which you have included in in this part rather than that class. We should include these in this part so that if we redefine the pins using this IOC uh, graphic interface pin definitions, it is not overwritten. So we build it again and see there still it's working. So thank you very much. We hope you have enjoyed it, and we will gradually build up our GPIO commands to include more and more functionality to and make our libraries so that we can use those commands later on in our future projects. Thank you very much.